Hello children, welcome back to my channel. I am now dealing with 7th class maths, the 10th chapter, new chapter, algebraic expressions. So under this name algebraic expressions, you are also having some portion you have studied in 6th class. In that you have talked about variables and constant terms and certain patterns you have learned. What are variables? Just let us have a small discussion about previous topic, then we will go to the next part. Variables means what? What is the meaning of vary? Vary means ever changing. Means it keeps on changing. So what variables we will be giving? Variables are nothing but, let me give an example of variables. Any letters are variables. Letters are variables. What are the example? X, Y, P, Z, A, B, etc. So on. Mostly we use X, that is why I have written X here. So these all are variables. And these variables, when they are kept in constant term, what are constant terms means? Numerical values. Numerical values are called constant terms. These numerical values you cannot change. See, as an example, I will tell. Suppose I take numerical value as 5. And suppose I have given x value, if x is equal to 2, then if I write 5x, 5x means what? 5 into x, that is 5 into 2, that is 10 is the value. Then if I give x value as 4, then 5x is nothing but 5 into x, 5 into 4, 5 4s are 20. See the change, children? These two changes are varying. We call them, the values are varying values. Varying values. So these values are changing or varying. Why? Because of this x value. Here x is 2, so you have got the value as 10. Here x is 4, so you have got value as 20. That means what? The variables are responsible for giving a value to a given number. So the constant value will not change. 5 is not changing. What is changing? The value of x is changing. So whatever value that we are giving to that x, we are getting different answers. So since the solutions are giving different values, all these letters are considered as variables. They are also called literal coefficients. You will be getting it in other places and all. So here at least you should understand what are variables, which you have already studied in the previous class. You have studied about variables, and basing on these variables, how certain patterns have come, all that you have prepared, you have learned in the previous class, children. This is only an introductory class where I have given an introduction about what you have already learned. I hope I am clear now about the variables and constant term. We will go to the exercise now. Just copy it. It is as an introduction. You can copy. Now we will go to the first exercise, children. The first problem is you have to find the rule which gives the number of matchsticks required to make the following pattern H and pattern V. So let us see the first one, pattern H. So if you want to make H, you need how many matchsticks, children? 1, 2, 3. This is 1, this is 2, this is 3. So number of matchsticks needed for H is equal to 3. So a pattern means how many H's are formed, number of H formed. We don't know how many. Pattern means it continues. We will be considering it as a variable n. So how many will be formed? Therefore, what is the pattern that you will be getting? The pattern that you will be getting is 1H needs 3. How many number are there? N. So 3n is the answer. The pattern will be having a formula of 3n. How many number of matchsticks you need? How many H? It is nothing but according to this pattern of H means number of H formed H's. It is like this H. So on it goes on. So how many we can say? We cannot, because they have not given any particular number. So many number of H's we want to form, like that they have not given. So we will be considering that the number of H letters that are formed is n. If they are n, for one H we need 3 matchsticks. How many we need? Totally 3n. So this is a pattern. Actually, this is a formula that we have made. So with the help of this, if any question has come, how many number of matchsticks are needed to make H letters, 10 H letters, if they say n value is 10, 3 into 10, 30 matchsticks you need. So suppose they wanted to make 15 matchsticks, 3 into 15, 45 matchsticks we need. So like that, we are actually developing a formula. A pattern here is nothing but a formula that we have developed to find out how many number of matchsticks are required for letter H. Now the second bit is a pattern of letter V. This I'll write a little bit the other side, because this problem, first problem has come here. So let me do the second one, a pattern of V. A pattern of V letter. So V means you are going to get one matchstick here and one matchstick here is enough. So number of matchsticks needed for V is nothing but 2. Now, how many number of V's formed? Number of V formed is nothing but n. Why do we call it as? It is because they have not given any particular number. So we are considering it as V. So what is the pattern that you will be getting? The pattern is nothing but 2 into n, that is equal to 2n. So this is another pattern. 3n is answer for it and 2n is answer for it, children. I hope I am clear to you. Just write down this. This is first problem. Now the second problem, children. Given below is a pattern made from colored tiles and white tiles. So this is considered as white tile. These are colored tiles. Now 1, 2, 3 patterns they have given in the problem. This is figure 1. This is figure 1. It is figure 2 and this is figure 3. 3 figures are given to you. You have got white tile and colored tiles. Now there are 3 bits here. First bit is draw the next 2 patterns, next 2 figures in the pattern. So first you should understand what is this pattern. This pattern is, you see children, one tile in the center, one here, one here, one here, one here. So around it, one colored tiles are there for one white tile. Here for one white tile, 1 2 1 2 1 2 1 2. So on all the sides, four sides, two colored tiles are there. Here on four sides, 1 2 3 1 2 3 1 2 3 1 2 3, three colored tiles are there. So all together you cannot means altogether you can count how many number of tiles are there here. So basing on this, the question here is draw the next two patterns. Next two patterns means, see, for a white tile one color tile here, for a white tile two color tiles are there, for a white tile three colors are there. So that means what? For a white tile, 1 2 3 4 tiles should be there, and for a colored tile, 1 2 3 4 5 tiles should be there on four sides. So four here, four here, four here. This got disturbed, so let me draw it properly. So this is the tile. So four tiles are there here. So these are all four. 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Here 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. So these are the next two patterns. Draw the next two patterns. So we call it as pattern 1, and this is pattern 2. This you have drawn. This is the solution for this children. Now, second problem, when you see, fill in the table and form an algebraic expression. You have to fill the table. So when you are filling the table, let us see, children. For 1 means you have got 4 colored tiles. For 2 means how many you have got? 1, 2, 3, 4, 5, 6, 7, 8 tiles are there. So you are writing 8 here. And for 3, number 3 figure, you have got 3 tiles, 3 colored tiles. Means see 1, 2, 3. So how many are there? Around it 3 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 tiles are there. So we have done 4. How many colors are there? See, 4. 1, 2, 3, 4. 1, 2. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 tiles are there. So we write the number 16 here. So when you have 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these are the ones you have got. So what is the algebraic expression? They are also asking algebraic expression. How are we getting algebraic expression, children? These all are, see, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20. So if you consider all these as n, then 4 into 1, 4, 4, 4 into 2, 8, 4 into 3, 12, 4 into 4, 16, 4 into 5, 20. So we are getting this as 4 times of n. So what is the algebraic expression you have got? 4n is your answer. Algebraic expression is 4n. Similarly, here figure they have given only one. How are you going to fill this? Let us see how we can fill it, children. See, 1 means if one white tile is there, 5 colored tiles. See, 5 means here equal number. If you keep 4, you have got. 5 means what? You have to take one more extra here. That means 1, 2, 3, 4 plus 1 extra. Then you will be getting 5. So here also, what you will have to take 2 means See, 1, 2, 3, 4, 5, 6, 7, 8 plus 1 extra, that is 9 you will be getting. 2 if you take, you need a 9. Okay. Next, when you go for the third one, how many we have got total? 12 we have got. And 12 means you need one more here. That is 13. Similarly, that means you see more than one here. This is a 12 and this becomes 17 and this becomes 21. So, if the number of tiles are n, then number of colored tiles, basing on this pattern only we are talking about, children. He is not asking 5. 4 means what we have got altogether 4 we said. So here also 5 means altogether 5. 5 means 1 extra you have to take. That means what? He is asking us to take 1 extra in every of these figures. 1 extra means what, children? Whatever color tiles you have got this, for that 1 extra you are going to get. So what is the formula that we have got? Here when you get 4n, this will be 4n plus 1. See, if n is equal to 1, what are you getting? 4n plus 1. How much you are getting? 4 plus 1, that is 5. If n is equal to 2, 4n plus 1, that is 4 into 2 plus 1, 8 plus 1, 9. See, we have got 9. So, n is equal to 3. 4n plus 1, that is 4 into 3 plus 1, 12 plus 1, 13. See, we have got 13. N is equal to 4. 4n plus 1. 4 into 4 plus 1. 16 plus 1. 17. See, you have got 17. Then n is equal to 5. 4n plus 1. That is equal to 4 into 5 plus 1. That is 20 plus 1. 21. You have got 21. So, it is in this way you can understand, the children, how it has gone. Your solutions are there for this problem, children. Please note it down. So, basing on this, what is the algebraic expression we have got, children? Algebraic expression is equal to 4n plus 1. This is the solution. 4n is the solution there. 4n plus 1 is the solution for the third bit. Now, third problem, children. Third problem is write the following statements using variables, constants and arithmetic operations. Means you have to make an arithmetic operation by using variables, that is letters, and constant terms, numbers, and with arithmetic operations plus, minus, into, division, any one of these values. So let us see the first one. 6 more than p. So what is the answer here? 6 more than p. For p you have to add 6. This is the answer, children. 6 more than p. And second one, x is reduced by 4. X is reduced minus 4 is the answer for it. And third bit, 8 subtracted from y means from y you are subtracting 8. This is the answer. And fourth bit, y multiplied by minus 5. Y into means you can write by in the bracket minus 5. That means minus 5y is the answer for it. And fifth one, y divided by 4. Y divided by 4. This is the answer for fifth one, children. And the sixth one, 1/4 of a product of P and Q. That means 1 by 4 of into product means P into Q. That means 1 by 4 PQ you can write, or PQ by 4 you can write. Anyway, it is the answer. Then seventh one, 5 are added to 3 times of Z. 3 times of Z, 3 into Z, 3 times of Z. To this 5 is added. That means 3Z plus 5 is the answer for it. And X multiplied by 5 and added to 10. X multiplied, answer for it, x multiplied by 5 and added to 10 means 5x plus 10 is the answer for it. And 5 subtracted from 2 times of y. From, after from which is there, you have to write that first. 2 times of y, 2 into y, from that 5 is subtracted. That means 2y minus 5 is the answer for this problem, children. And the 10th one, y multiplied by 10 and added to 13. Y multiplied by 10 and added to 13. This is added to 13. That means 10y plus 13. These are the answers for this sum, children. Please note it down. This is third problem. Fourth sum, children. The fourth sum says, write the following expressions in statements. In the earlier problem, they have given statements and they have given expressions. By taking the expressions, you have written, sorry, they have given statements, you have written expressions. Now they have given expressions, you need to write the statement. So, x plus 3. What you will write? 3 is added to, or x is added to, x is added to 3. When you add x to 3, x plus 3. And this is y minus 7. 7 is subtracted from y, because what is this first letter should come after from. 7 is subtracted from y, and this is L is multiplied by 10. L is multiplied by 10. 10L. There is no symbol, plus or minus symbol is not there, means what should you understand? That these two are multiplied. Now, x by 5. That means x is divided by 5. Next, 3m plus 11. This means 11 is added to 3 times of m. So to 3 times of m, 11 is added. And this is 2y minus 5. That is 5 is subtracted from 2 times of y. Twice of y. You can write twice of y. Twice of y means what? Twice means the other way, 2 times of y. Anything you can write, twice of y or 2 times of y. So these are the answers for this problem, children. Please note it down. Now the fifth problem is some situations. This is fifth problem. So some situations are given below. State the number in situations is variable or constant. I told you earlier that variable means only letters. Here in this problem, they are asking about the numbers. So there is a possibility, children. In some cases, even the numbers will be considered as variables. So what are those situations in which the numbers we are going to consider as variables? Let us see the first one. The number of days in the month of January. So how many number of days are there in the month of January in any year? Will they alter? They won't alter. So we will call them as constant numbers. So these are all constant. The numbers are constant. Why? Because they are. This is the answer. So I'll write answer here. Answer constant. The numbers are called as constant values. They are considered as constant because the number will not alter in January. Temperature of the day. See children, day as the day increases, the length of the day increases. That means early morning temperature will be less. Gradually, as the day proceeds, the temperature will increase. Up to midday, at afternoon, exactly at 12 o'clock, it will be very hot. Then gradually the temperature will reduce. And the moment when it comes to the night, it will go down to a lot extent. So there is a continuous change in the values of the temperature. So that type of ones are called as variable. So the answer here is variable. The numbers given here are variable numbers. Length of your classroom. Length of the classroom. Classroom never changes. Its length will not change. So we will be calling it as constant. Next. Height of the growing plant. When the plant grows, first it you see with a seed, you'll be getting seedling. So slowly the seedling will grow into plant. The plant, if it is going to be a tree, it becomes very big tree. So herbs, shrubs, everything you have learnt in your science. So if it is the product of a big tree, it becomes a very big tree. So the size of the tree keeps on varying. So we will be calling it as variable. So when I was talking in the first when I started teaching you this video, in this video, I said that variables are letters, constant ones are numbers, and I said that numbers will not alter. So, since variables, letters are altering, we call them as variables. But see, the end of this, I'm going to end this video now. We have come to the conclusion that it is not only the letters, even the numbers are variable. But usually it is something trickish because never we see numbers varying. We will not say varying numbers. But here, certain situations exist which make the numbers as variable. So those situations are given here, like growing a tree, moving the range, the different ranges of temperature, and even rainfall, the value of the rainfall, and like this, various examples you can take. And those are numbers only, but the numbers keeps on varying. So when the numbers keep on varying, those are considered as variable numbers. So even numbers in certain situations, we will consider them as constant, and in certain other situations we will consider them as variable. That means here We are only talking about the numbers. No letter is given here, children. When we are talking about these numbers, letters will not come into the scene here. When letter comes, then only letters are variables, number will not be the variable. Okay, I hope I am clear, children. Please note it down. This is fifth sum. With this, I am ending up today's class. In the next class, I will be doing the next part of the lesson.